Lipid metabolism is the body's invisible fuel system, turning fats into energy, building blocks for life, and sometimes silent contributors of the disease. Maayad haaldaw ta inyo alan. Good day everyone. Today we will be tackling about lipid metabolism. So there are three objectives that we need to get this morning. So the first one is to compare and contrast the metabolic fates of dietary and endogenous lipids. The second one is to analyze the regulatory mechanism controlling lipid metabolism and their implications for health. And the third one is to evaluate the clinical significance of lipid metabolism disorders and potential therapeutic interventions. And for the introduction, lipid metabolism involves the synthesis, the breakdown, and the utilization of fats essential for energy production, cellular structure, and hormone synthesis. So this report addresses the metabolic pathways of dietary and endogenous lipids, regulatory mechanisms, and clinical implications of lipid metabolism disorder. So today, we will be tackling what is the metabolic fates of dietary versus endogenous lipids. So exogenous or dietary lipid pathway. So first is the digestion. Dietary triglycerides or TGs are emulsified by the bile salts in the duodenum and hydrolyzed by pancreatic lipase into monoglycerides or MJs and free fatty acids or FFAs, cholesterol esters are esterified free cholesterol. Another is the absorption. These components form micelles for intestinal absorption. Inside the enterocytes, they reassemble into TGs and cholesterol packaged into chylomicrons. And the third one is the transport. Chylomicrons enter the bloodstream via lymphatics in the adipose muscle tissue. Lipoprotein lipase or LPL breaks down 90% of TGs into FFAs for storage or energy. Cholesterol-rich remnants return to the liver via ApoE-mediated uptake. So in summary, when we say the exogenous or the dietary fat pathways, when you eat fatty foods, your body breaks them down in your gut into tiny pieces like fatty acids and cholesterol. So this get wrapped into delivery tracts called chylomicrons. What is the delivery tract? It is called chylomicrons that enter your body. As they travel an enzyme called LPL like a key. So LPL is like a key, unlocks the fats, so your muscles cost them for energy or your fat cells can store them. So after dropping off most fats, then now the smaller tracts called remnants return to the liver to deliver leftover cholesterol which your body reuses or gets rid of. And the next one, we need to tackle the endogenous lipid pathway. So what is endogenous lipid pathway? So in synthesis, the liver produces very low density lipoproteins or VLDL containing the TGs, and cholesterol or VLDL releases FFAs to tissues via LPL becoming VLDL remnants. So in conversion, IDL either returns to the liver or transforms into low density lipoprotein or LDL, which delivers cholesterol to peripheral tissues. LDL contributes to the atherosclerosis. So what is, in summary, of endogenous lipid pathway? So the endogenous lipid pathway is how your body moves fats and cholesterol that makes itself through your blood, or it makes itself not from food through your blood. The liver creates VLDL, a type of fat-carrying particle which travels through your bloodstream and drops off fats to your body cells with the help of the enzyme called LPL, and VLDL loses fat, it becomes IDL, which either goes back to the liver or turns into the LDL, or LDL mainly carries cholesterol and delivers it to cells that need it. But if there's too much LDL in your blood, it can build up your blood vessels and cause blockages, increasing the risk of heart disease. So that's it for my report about the exogenous or the dietary fat pathways and the endogenous lipid pathways. I hope that you learned something for my report. Thank you so much.
Good morning, everyone. Today, we're diving into a crucial aspect of lipid metabolism, how our body transports fats in the bloodstreams, given that fats don't mix well with the water. This is a complex but vital process. We'll be discussing lipoproteins, the specialized particles that make this transport possible. So let's start with the fundamental problem. As we learned previously, lipids such as triglycerides and cholesterol are hydrophobic. They don't dissolve in water. But our blood, which is primarily water, needs to carry these lipids to various tissues for energy, storage, and cellular function. So how does the body solve this problem? So lipoproteins are like tiny transport vehicle. They're complex particles with a core of hydrophobic lipids, mainly triglycerides and cholesterol esters, surrounded by a shell of hydrophobic substances, including phospholipids and proteins called apolipoproteins. So these structures allows them to travel through the watery environment of the blood. So now let's look at the different types of lipoproteins. So they're classified based on their density, which is determined by the ratio of lipids to proteins. So we'll start with the largest and least dense, the chylomicrons, which are the largest and least dense. So what is their primary role? So chylomicrons are like the delivery tract that transports dietary triglycerides, the fats we absorb from our food, from the intestines to tissues that need them, primarily muscles for energy and adipose tissue for storage. So next we have VLDL. Where are they synthesized and what do they carry? So very low density lipoproteins is produced in the liver. It's responsible for transporting triglycerides that are synthesized within the liver itself. So these are called endogenous triglycerides to peripheral tissues. So now we come to low density lipoproteins, or LDL. How are LDLs formed and what are their main cargo? So as VLDL particles circulate and deliver triglycerides, they become smaller and denser, eventually transforming into DLD, which is primary cargo is cholesterol. And it carries these cholesterols to peripheral tissues. So this is why the LDL referred to as bad cholesterol. So why is LDL considered bad? High levels of LDL cholesterol contribute to the buildup of plaque in the arteries, a process called atherosclerosis. So this can lead to heart attacks, strokes, and other cardiovascular problems. So maintaining healthy LDL levels is really important. So finally, let's discuss HDL. Where does HDL come from? And what does it do? So HDL, or the high density lipoproteins, is synthesized in both the liver and the intestine. Its function is quite different from LDL because HDL involves in reverse cholesterol transport. It collects cholesterol from peripheral tissues, including the arterial walls, and transports it back to the liver. So why is HDL called good cholesterol? By removing cholesterol from the arteries, HDL helps to protect against atherosclerosis and cardiovascular diseases. So this is why higher level of HDL are associated with a reduced risk of heart disease. Now let's talk about a crucial enzyme in the process, lipoprotein lipase, or LPL. Where is LPL located and what does it do? So LPL is located in the inner walls of blood vessels, specifically the capillaries, in tissues like muscle and adipose tissue. So its primary function is to break down the triglycerides carried by chylomicrons and VLDL. So how does LPL work? So LPL hydrolyzes the triglycerides, meaning it breaks them down into their component parts, free fatty acids and glycerol. So these free fatty acids are then taken up by the surrounding cells. So what happens to these free fatty acids? Muscle cells use the fatty acids for energy production, while adipose tissue stores them for later use. So LPL activity is carefully regulated by hormones such as insulin, which, for example, increases LPL activity in adipose tissue to promote fat storage after a meal. So to wrap up, let's summarize the key points of lipoprotein metabolism. So in essence, lipoprotein's metabolism is a dynamic and tightly regulated process that involves the synthesis, transport, and breakdown lipoproteins. So chylomicrons and VLDL delivers triglycerides, while LDL delivers cholesterol, and HDL plays a protective role by removing excess cholesterol. And LPL is the key enzyme that enables the delivery of the fatty acids to tissues. So what are the clinical implication of this process? So imbalances in lipoproteins levels, particularly in LDL and low HDL, are the major risk factors that atherosclerosis and cardiovascular diseases. And so understanding this process is crucial for preventing and managing these conditions. So that's all. Thank you.
So now let's discuss the ketone body metabolism. So what are ketone bodies? So it is a water-soluble molecules produced in the liver from fatty acid during low glucose availability. So they are types of ketone body metabolism: the acetoacetate and the beta-hydroxyl butyrate and acetone. So these are alternative fuels for the brain and muscle when glucose is low, especially during fasting, low carbs diets, or uncontrolled diabetes. So during periods of prolonged fasting or starvation, when glucose availability is limited, the liver produces ketone bodies, acetoacetates or beta-hydroxylbutyrate and acetone from fatty acid. So these ketone bodies can be used as an alternative fuel source by the brain and other tissues. However, excessive ketone bodies production or ketoacidosis can be dangerous, leading to metabolic acidosis. So when are ketone bodies produced? So it is produced during prolonged fasting or starvation, low carbohydrate intake, and type 1 diabetes mellitus or insulin deficiency. So when insulin levels are low, fat breakdown increases. So the liver converts fatty acid into ketone bodies for energy. So next is ketogenesis pathway. In liver mitochondria, fatty acids produce acetyl CoA or acetoacetate, produce BHB plus acetone. So the liver produces ketones but cannot use them. Instead they are released into the bloodstream. So next is the cholesterol metabolism. So what is cholesterol metabolism? So a lipid molecule or a component of cell membrane, precursor for hormones, estrogen, testosterone, and converted into bile acids. So cholesterol is a component of cell membranes and a precursors for steroid hormones. So the liver synthesizes cholesterol de novo and also takes up cholesterol from LDL. Cholesterol is excreted from the body primarily via bile acid or regulation of cholesterol synthesis and uptake is very important for maintaining cholesterol osmosis. So cholesterol synthesis. So it starts with acetyl or CoA and converts acetyl into mevalonate cholesterol. So an HMG or CoA mag-reductase is the rate-limiting step and a major target for statin drugs or cholesterol-lowering medication. So the transport of cholesterol lipoproteins. So LDL, low-density lipoprotein, it delivers cholesterol to tissues or bad cholesterol. And HDL or high-density lipoprotein, it collects excess cholesterol or good cholesterol. So high LDL level is risk of atherosclerosis, and HDL helps clear cholesterol from the blood.
So, good morning. So, I am Michael Campo and I will be your reporter today and our topic is lipid synthesis or also known as lipogenesis. So, by the way, what is lipogenesis? So, it refers to the metabolic process by which the body creates fatty acids and ultimately triglycerides or also known as fats from non-lipids precursor, primarily carbohydrates. So this process occurs mainly in the liver and in adipose tissue and is most active in feed state. So by the way, what is feed state? So feed state refers to the period right after eating a meal when your body is digesting and absorbing nutrients. During this time, blood glucose levels are high and insulin is released from the pancreas and the body is focused on storing energy and not breaking it down. So in the feed state, the body stores glucose as glycogen and in the liver and muscles, and it converts extra glucose into fat via lipogenesis and promotes protein synthesis. So now let's move on to the importance of lipid synthesis. So lipid synthesis is important for energy storage. When you eat more calories than your body needs, especially carbs, lipogenesis converts the excess into fat for long-term storage. This stored fat is your body's backup energy supply. Now, it is your fuel for later when food isn't available, maintaining energy balance. And also, lipogenesis helps regulate blood sugar by removing excess glucose from the bloodstream and turning it into fat. This keeps your metabolism stable and prevent blood sugar. So, that's the reason why runners, those who run marathons, they eat a lot of carbs for energy storage. And they call it carbo loading. So the another importance of lipid synthesis is for building blocks for the body. Fatty acids are used to make cell membranes, especially phospholipids, hormones like steroids hormones, signaling molecules important in inflammation, growth, and repair. And also, it supports growth and reproduction. So, in reproduction, in periods of growth like puberty or pregnancy, the body needs extra lipids for making new cells, hormone production, and storing nutrients for fetal development or breastfeeding. Now, let's move on to the key steps in glycogenesis. So, the first is glucose uptake and glycolysis. So, glucose enters the cell and undergoes glycolysis, producing pyruvate. So, pyruvate, by the way, it is a small but super important molecule in the metabolism. It is the end product of glycolysis, which is the process that breaks down glucose or sugar for energy. And pyruvate enters the mitochondria and is converted to acetyl-CoA. So, acetyl-CoA, by the way, is a central molecule in the metabolism, acting as a carrier for two carbon units in acetyl groups, no? So, it is involved in a wide range of biochemical reaction, including energy production. So, the second one is citrate shuttle. When energy is abundant, acetyl-CoA combines with oxaloacetate to form citrate, and citrate is transported out of the mitochondria into the cytoplasm. And in the cytoplasm, citrate is converted back to acetyl-CoA by ATP citrate lyase. So the next step is the fatty acid synthesis. Acetyl-CoA is converted to malonyl-CoA by acetyl-CoA carboxylase. The rate-limiting steps of fatty acid synthesis or FAS catalyzes the formation of long-chain fatty acid, mainly palmitate, no? So 16 carbon saturated fatty acid using acetyl-CoA and malonyl-CoA. So in summary, lipogenesis allows the body to store excess energy from carbohydrates as fat, and it is tightly regulated process that ensures energy balance and is closely linked to overall metabolism, insulin sensitivity, and diseases like obesity and type 2 diabetes. So that would be all. Thank you.
We're down to the disorders of lipid metabolism. Disorders of lipid metabolism, also known as lipid metabolic disorders, are a group of conditions that disrupt the body's ability to process and utilize fats or the lipid. This disorder can lead to a buildup of harmful lipid in our body. Okay, the cause of a lipid metabolism disorders. The primary cause of a lipid metabolism disorders is genetic mutation. These mutations affect the production of functions of enzymes involving in a lipid metabolism. These enzymes are crucial for breaking down lipids into usable energy sources or transporting them throughout the body. Okay. Cause of a lipid metabolism or the genetic
disorders or the Gaucher's diseases is a genetic disorder affecting the enzymes glucocerebrosidase, which breaks down into a specific type of fat. This leads to a buildup of fat in the various organs, primarily in the spleen, liver, and the bone marrow. Okay, the Tay-Sachs disease, a genetic disorder affecting the enzymes hexaminodase, hexaminodase A, responsible for a breakdown of a specific type of fat in the brain, leading to the buildup of a fatty substance called a ganglioside in the brain and nerve cells, ultimately damaging the brain and the spinal cord. Uh, Lifestyle impact the lipid metabolism through diet affecting cholesterol levels, physical activities influence fat breakdown and storage, and stress and sleep pattern moderate hormonal regulations of a lipid processes. A balanced diet, regulate exercises, and stress management are crucial for healthy lipid metabolism. Next is underlying medical conditions. Certain medical conditions also can lead and contribute to a lipid metabolism disorder. These conditions include diabetes. Diabetes can lead to a increase of triglycerides levels and reduce the HDL cholesterol or the good cholesterol. Next is the hypothyroidism. Hypothyroidism can slow down metabolism, leading to increased cholesterol levels. Next is the kidney disease. Kidney disease can affect the body's ability to remove waste product including cholesterol. Next is the hyperlipidemia, or cause of characterized by elevating of levels of lipids such as cholesterol and the triglycerides in the body. Excuse me. High levels of lipid in the blood can contribute to the development of atherosclerosis, a condition where plaque builds up in the arteries, increasing the risk of heart disease and stroke. Next is atherosclerosis. Atherosclerosis is a condition where a plaque, primarily composed of cholesterol, builds up inside the arteries. Effect of atherosclerosis can lead to various cardiovascular patterns, including heart attack, strokes, and peripheral artery disease. Obesity is characterized by excessive accumulations of body fat caused by an imbalance between calorie intake and calorie expenditure. Obesity increases the risk of developing various health problems, including heart diseases, type 2 diabetes, and certain type of cancers and osteoarthritis. Next is the fatty liver diseases. This can cause by excessive alcohol consumption, obesity, diabetes, and other medical conditions. Fatty liver disease can progress to more serious forms such as non-alcoholic steatohepatitis or the NASH, which can lead to a liver damage, cirrhosis, and liver failure. In conclusion, lipid metabolism is vital for energy, cell structure, and hormonal production. Dietary lipid digestion, lipoprotein transport, and fatty acid oxidation provide energy. Ketone bodies after the alternative fuel source during fasting. Cholesterol synthesis is crucial for cell membranes and hormones, while lipogenesis creates lipid from excess nutrient. Regulating exercise enhances regular exercise enhances lipid utilization, improve insulin sensitivity, contributing to overall metabolic health. Hormonal regulation and metabolic disorders significantly impact this complex system. That would be all. Thank you and good morning.